Alright, Dave, well, hold on. I gotta move my tag out of there. Alright, Dave, I'll explain in this video RSA. It's like this tizite encryption algorithm. It's awesome, dude. Alright, so check it out. Alright. So, for RSA to work, you need two different keys. One to encrypt the shit, and another to decrypt the shit. And in order to generate these two keys, here's how you do it, alright? So you start out, and you get like two different prime numbers. You just random, whatever you want. And they gotta be big, This is based on the RSA key size. So if your key size is 128 bits, you choose two 128-bit prime numbers. If it's 64-bit, you choose 64-bit numbers. Whatever. Bigger the better. Mostly. Because if it's bigger, then it's harder to crack. So once you have your two prime numbers, we'll call these P and Q. Alright? So you need to generate the public key and the private key. The public key is what I give, if let's say I'm doing RSA, right? I have two keys. I have my private key and I have my public key. I give my public key to anyone. And they can encrypt any message they want with my public key. And the only thing that can decrypt it is my private key. So no one else can decrypt it except for me. And vice versa. I can encrypt shit with my private key. And then no one else can decrypt it. Wait. People can only decrypt it with my public key. And so they know it's from me. And if someone wants to send a message just to me, then they can encrypt with their with my public key, and I'll decrypt with my private key, because I'm the only one that has it. So I'm the only one that gets that message. So that's basics of asymmetric encryption. It's pretty easy, pretty simple. Okay, so to actually generate these keys, you need three values. One is known as N, and that's in both the public key and the private key. One is known as E, and one is known as D. E is in the public key. The public key consists of E and N, and the private key consists of D and N. So it ends in both of them. N is like the modulus. You get a mod by it. So it's a little complicated, but basically think of it as like the maximum number of shit you can encrypt or decrypt at one amount of time. That's pretty much it. It basically, instead of having a result that's like this big, it makes your result like this big. And this big, this distance right here, is N. So that's pretty much what N is in the abstract sense. So in order to calculate N, you take these two prime numbers that you generated, P and Q, and take what's called the totient of the product of these two. So P times Q, that's the product. And the totient is the number of non-prime numbers, I think. It's something like that. But basically, since P and Q are both prime, then the number of non-prime numbers, or I guess they'd be called composite numbers, would be P minus 1 times Q minus 1. And there's some math behind it. Just believe me. I'm right, and you're wrong. Just believe me. Okay, so you got N by taking the quotient of P times Q. Cool, alright. Now, you gotta generate E. And E is just... Oh, shit. I dropped my keyboard. Hold on. Okay. So, E is anything you want. You just generate some random number, alright? And that's your E. Alright, but then you gotta calculate D based on E. And Shit. What is a relationship? And then you calculate D, I forget how, but basically, I think it's like you want the inverse something to be 1, you know, based on E. So you set them up, you know, whatever. You know, that's whatever, dude. So after you get E and D, then you have N, and you have both your public key and private key. So you got public key and your private key. So I give you my public key, and I keep my private key. I'm the only one that sees my private key. But everyone else can have my public key. And then I encrypt my message with my private key, and I send it out to everyone. And everyone with my public key can decrypt it. And if my public key decrypts it, that means that my private key encrypted it. And that means it's from me for sure. And same thing, you know, applies for the reverse. So if you wanted to send me a message, a secret message, you encrypt it using my public key. And the only person that can read it is the person with my private key, which is me, which is awesome and secure. Now the exploit here, and the way to crack RSA, is, so if you have my public key, you have that N, and N is based off of P and Q help generate E and D. But you already have E, I think it is. No, you already have D, because the public key is D and N. So you can get E based off of D and N. But the only way you can do that is if you can factorize. Is that a word? You can factor large numbers. If you can do the prime factorization of large numbers, which no one can do. It's a hard, long process, and no one can do it in a reasonable amount of time. That's pretty much RSA.